Alright guys, so what we're covering today is section 7.43. Now some of the stuff we'll be covering in this here is dealing with the denominator, the bottom of these partial fractions, when we split it up, being a quadratic or something greater than a first degree polynomial. Now when we look at this here, the degree of the top is less than the degree of the bottom, so that's good, so we don't have to do long division on this or simplify it down. We're good there. So the first thing we will need to do is to factor the denominator. Now the first thing I notice is that there's a greatest common factor of x, so I can factor it out, which gives me x times x squared plus 4. Now x squared plus 4, you might be tempted to say that is factorable and we could factor it, but it's actually not. If it was x squared minus 4, then we could factor it. But x squared plus 4 is not factorable. So our fraction here, when we rewrite it out, we have 3x squared plus 4x plus 4 over x times x squared plus 4. So here we have two things that are multiplied together because we just have x, so we don't have x to any power. We don't need any extra parentheses for that. And we just have x squared plus 4. There's only one of them. So we're only going to have two fractions. We'll have one that's over x, and one that has x squared plus 4, or something over x squared plus 4. Now we're going to put in our letters. So here we're just going to have a, just like we've done in the previous lessons. But this time we have x squared plus 4, so this is a little bit different. Because again, as I've said already, the degree of the top is going to be 1 less than the degree of the bottom. Well, the degree of the bottom here is 2. And we're not really looking at if it had parentheses around it squared. We're looking at this here. This is a quadratic. So what can be above it is going to be bx plus c. It can have a degree of 1. And because it has a degree of 1, we will have a variable. So that's what makes this one here a little bit different. Now there's going to be some other differences when we start solving, and we'll get to those here in a minute. Now that we have it broken up and set up like this here, we're going to do our same kind of steps as we've been doing before. We're going to multiply through by the greatest common denominator, so x times x squared plus 4. X times x squared plus 4. And x times x squared plus 4. Now, all of this here is going to cancel out with all of this here. X and x squared plus 4, and x squared plus 4. So what we're left with is 3x squared plus 4x plus 4 is equal to a times x squared plus 4 plus bx plus c, this whole thing multiplied by x. Now at this point here in some of the previous lessons, we went on and found the values of x that would make either this 0 or this 0 and then solved. But there's one key difference between that one and this, is that we have these x squared and other terms over here. And because of this difference, what we're going to do is we're going to multiply through. We're actually going to multiply these together. So it's not going to affect the left side, our 3x squared plus 4x plus 4. This is going to stay the same. Now over here we're going to have a times x squared, which gives us ax squared plus 4a. Plus, then we're going to multiply through by x, so we get bx squared plus cx. And we have this here. Now what I'm going to do next is I'm going to group the things that have like terms. So if we notice, I'm going to use my highlighter, ax squared, so this has an x squared. Bx squared also has an x squared. So we're going to put those two together. Those are the only thing on the right side that have something in common, a common term. So what we get is 3x squared. So what we have over here is 3x squared plus 4x plus 4 is equal to, so ax squared plus bx squared plus cx plus 4a. And I just rewrote it in terms of descending power, so x squared came first, x, and then our term with no x's. x squared plus 4x plus 4. Now what I'm going to do is I'm going to factor the x squared out of this. So we have x squared times a plus b plus cx plus 4a. So we get this here. Now, what we're doing, again, this is different than what we've done before. What I notice is that we have our x squared, we have an x, and we have 4. Grab my highlighter. So we have this x squared and this x squared here match up. X and x, 4 and 4. These here match up. So what this is kind of telling me, let's get this blue, that this here and this here are going to match up. This here and this here are going to match up. And last but not least, get this kind of gray color. That our A is going to match up with this here. Because they're going to kind of go together. Our x squared, x squared. These sides, again, like I said before, are equal. They are equal to each other. And we use the plugging in of the different numbers to get 0 to kind of help us work through what is matching up. But here it'd be a little bit harder to do that. So what we're doing is regrouping it to connect these two together. And to connect these two together. And then connect these two. So kind of what we're saying is that 3x squared, this term here matches up with our x squared times a plus b. Our 4x is matching up with cx. And our 4 is matching up with 4a. Now, in this here, we're not worried about the x squareds. Really, we're saying 3 is equal to a plus b. Here, again, we're not really worried about the x's. We're saying 4 is equal to c. And here we can leave it alone because we don't have any variables. Now, this is kind of helpful because, well, voila, 4 is equal to c. Now this one here, we can't solve for 2 variables at the same time. We have to solve for 1 at a time. So let's go over here. 4 is equal to 4a. Well, I can solve this one for a by dividing both sides by 4. And we get 1 is equal to a. Awesome. We now have 2 variables, 2 letters, a and c solved for. So what I can do here is I can plug in for the value of a. We know it's 1. So we get 3 is equal to 1 plus b. To solve for this here, we can subtract 1 from both sides, which tells us 2 is equal to b. And that's it. We have now solved for each of the 3 letters, A, B, and C. So what I'm going to do is I'm going to come back up here to the top and grab this here and everything else that's going along with it. Bring it down here, and apparently I didn't get everything. So what we started out with is A over X plus bx plus c over x squared plus 4. This was our partial fraction decomposition we were working with. And we were trying to find the values of a, b, and c. Well, we found the value of a to be positive 1. So we plug that in. Then we also found the value of b to be 2, positive 2, and we found the value of c to be positive 4. And that's all we have to do for this here. So let's look at another example. Okay, so looking at this next problem here, we see that the degree of the numerator is less than the degree of the denominator, which is good. So we don't have to do any long division to simplify down. Now what we can do next is factor the denominator, x cubed plus x. Well, x cubed plus x has a greatest common factor of x, so we can factor it out, which gives us x squared plus 1. Now x squared plus 1 does not factor, that is as far as it goes. And we've got that completely factored now. So the numerator is still going to be 2x squared minus 5, and the denominator is going to be x times x squared plus 1. So here we're going to have two fractions. The denominator is going to be x and x squared plus 1. And we only have one of each of those. So we only have two. I only have one of this, I only have one of that. Now our lettering, so we're going to have A, and then here we're going to have B, X plus C. And the way that we do the letters is I'm just going to start here with A. There's only one letter, so I just stick with A. Here, because of the quadratic, I'm going to have B, X plus C. And then I'm just going to keep going. So if I needed another letter on top, it would be D, and then E, then F, and we just keep going down the line. I'm going to save that for a later date. Now, what we're going to do next is we're going to multiply through by the greatest common denominator. So we're going to multiply everything by x times x squared plus 1. X times x squared plus 1. And x times x squared plus 1. And we multiply everything through by this here. These here cancel. X and x cancel. X squared plus 1 and x squared plus 1 cancel. And what that leaves us with is 2x squared minus 5 is equal to A times x squared plus 1 plus bx plus c times x. Now again, just like with the last problem, we're going to multiply through on the right side. So 2x squared minus 5 does not change. Here we're going to have ax squared plus a plus, so we're distribute the x, bx times x is bx squared plus cx. These two here both have x squared, so 2x squared minus 5 is equal to, so we'll have ax squared plus bx squared plus cx plus a. Since these both have x squared in it, I'm going to go on and factor it out. So we'll have x squared times a plus b plus cx plus a. Now just like before, we're going to match these up. So our 2 is going to match up with our a plus b. Our negative 5 is going to match up with a. And our term that's right here in the middle, not the x squared, there's a term right here in the middle, is going to match up with our cx. And we'll do that and cover exactly what that term in the middle of those two is here in a minute. Now what I know for certain is that 2 is equal to a plus b. And we also know that negative 5 is equal to a. Those match up. Now our c is going to match up to something also, because I have a cx term here. Do I have a term with just x over here? Well, no. So there actually is a term written in there. The term that's written in here is 0x. So c is going to match up with 0. C is going to match up with 0. Just because we have a letter over here does not mean, or a letter and variable doesn't mean it's not going to match up to something over here. Just because it's not written doesn't mean it's not there. It's just 0 times it. It disappears. It's just not written in. So, well, they gave us the value of c already. And hey, look, they gave us the value of a. So now we just need to solve for this one over here. Solve for the value of b. So what I can do is I can plug the value of a in as negative 5 plus b. Our next step would be to add 5 to both sides. And when I add 5 to both sides, I get the value of b is 7. bring these two down. So now we have all three letters, A, B, and C. Down from earlier. So now we can plug back into our partial fraction decomposition. We found out that the value of A is -5. The value of B is 7. And the value of C was 0, so it just goes away. So our answer for this one here is -5 over x plus 7x over x squared plus 1. And that's our answer for this here. Now we're going to look at two more examples in this this section here. And that's going to be these two here. Now when we look at this here, it's very tempting to say that the degree of the top is greater than the degree of the bottom. It's very tempting to say that. But really, we have this thing squared. So really the degree of the bottom is not 2, it's actually 4. The degree of the bottom is 4. It just worked out that it was x plus 2 times x plus 2. And x plus 2 times x plus 2 would give us x to the 4th plus 4x squared plus 4. And they went on and factored that for us. They went on and factored that for us to get x squared plus 2 squared. So we wouldn't have to factor that. So they went on and gave that to us. So the degree of the bottom for this is 4. The degree of the top is less than the degree of the bottom, so we're good there. This is already factored. So what we can do is we can write out our fractions. Now looking at this here, because it's squared, I have two of them. I have x squared plus 2 as one of my terms. Now the other one is going to be x squared plus 2 squared. Now again, this is a quadratic, so we'll have ax plus b, and then we'll have cx plus d. Now we're not worried about the thing multiplied together, that 4th degree. It's just the 2nd degree, what's inside here, is what's important. It is a quadratic. And we get this here. Now at this point here, now I'm going to use copy and paste to bring it down just a little bit so I can work with this here. And what we're going to do is we're going to multiply through by the greatest common denominator. So x squared plus 2 squared. X squared plus 2 squared. And then we'll multiply this one here by x squared plus 2 squared. Now, one thing that is nice is that these two here do cancel out completely. This one here cancels out with one of these. And these two here cancel out completely. So what we're left with is 8x cubed plus 13x is equal to ax plus b times x squared plus 2, because we had one left over, plus cx plus d, because these canceled out completely. They were gone. I still had one here. Now what we'll do next is we'll have to distribute here in the middle. So 8x cubed plus 13x does not change. Ax times x squared gives me ax cubed. Ax times 2 is plus 2ax. B times x squared is plus bx squared. B times 2 is plus 2b plus cx plus d. Now at this point here, we need to group all of the like terms on the right side. So x cubed is the only term with x cubed, so we have it by itself. B squared is the only term with b squared, so we have bx squared. Now our term with x is we have 2ax and cx. So 2ax plus cx, and then we have plus 2b and plus d are ones without any variables, any x terms. Now we can group the ones in the middle, plus 13x. So ax cubed doesn't change. Bx squared is fine. But here We have a common term of x, so I'm going to factor it out. So we get x times 2a plus c plus, I'm just going to put parentheses around this, 2b plus d, because they're like terms. So kind of like what we did on the last two, we're going to match them up. I'm going to get my highlighter out. So our a is going to match up with our 8. 13 is going to match up with our 2a plus c. Now you're probably wondering, well, what about the others? So not written over here is we have also 0x squared and 0. These two terms are not written in right here. But they still have a pair they match up to, because our 0x squared is going to match up to b. Well, not the 0x squared, but just the 0 matches up with our b. And 0 matches up with 2b plus d. Now, if you're thinking back to the previous problem, you're like, okay, well, those zeros are going to work out great. They're going to line up. Some of them, yes, some of them, no. Because let's look at this. Now, what we had said was a is equal to 8. A and 8 match up. Bx squared, so b matched up with 0. So that's great. Now, the next one, it said that 2a plus c was equal to 13. And 2b plus d was equal to 0. Now, out of all of these here, a equals 8, b equals 0. Those two were just straight given to us. Those two equations were given to us. So what I can do is I can use this for this part here, because we know a is 8, so we have 2 times 8 plus c is equal to 13. 2 times 8 is 16, plus c is equal to 13. Subtract 16 from both sides, and when I subtract 16 from both sides, I get c is equal to -3. So that gives us our value of c. Now in our last one, we know what the value of b is. b is 0. So we have 2 times 0 plus d equals 0. Well, 2 times 0 is 0, so I have d is equal to 0. And we are done. We have all of our values here. So I'm going to move try to move these. So we get these here. I'm going to move them down here, level up. Get them all on the same level. And now what we had to start with when we were solving this here is we had that ax plus b over x squared plus 2 plus cx plus d over x squared plus 2 squared. Now we found the value of a, and we said that the value of a is 8. And then we found the value of b is 0, so it's gone. Now the value of c we found to be -3, and the value of d was 0 as well. So we get this here. And if you want, we can really we can level those up. So if I wanted to rewrite it as 8x over x squared plus 2, and I can move the negative over and say minus 3x over x squared plus 2 squared. And this right here is our answer, and that's all we have to do for this problem here. Now we're going to look at one last type of this here, and we will be done with 10.43. Now this here, again, kind of like the last one, the degree of the bottom is actually bigger than the degree of the top because of this square. We actually have a degree 4 in the bottom. And because I have two of them, we'll have two fractions. So the first one's going to be x squared plus 4. And then we'll have x squared plus 4 squared. And on top, we're going to have ax plus b. Here we're going to have cx plus d. And that's it so far. Now the next thing we'll do is the same thing as what we've been doing, is we're going to multiply by our greatest common denominator, x squared plus 4, x squared plus 4 squared, and x squared plus 4 squared. Now for us here, these will cancel. One of these will cancel with one of them, so we still have 1x squared plus 4 being multiplied here, and these two cancel out completely. So what we have left is, well, on the left side, we have x cubed plus 3x squared minus 2x plus 7. So I have all my terms here, cubed, squared to the first, and our constant. Over here, we're going to have ax plus b times x squared plus 4 plus cx plus d. Now we still have to multiply our two together. This ax plus b and x squared plus 4. So ax times x squared is ax cubed. Ax times 4 is plus 4ax. B times x squared is plus bx squared. And lastly, we have plus 4b plus cx plus d. And at this point here, again, on the right side, I'm going to group the like terms. Well, there's no other terms with x cubed, so we have it there. X squared, again, is by itself. It's the only term over here that has x squared. Now we have 4ax and cx, so I have plus 4ax plus cx plus 4b plus d. Now at this point you're saying, why don't we just combine them? Well, ax and cx are not actually like terms. I said that they were, but they're not actually like terms. And when I'm talking about like terms, I've been talking about it in these last few sections, I'm really referring to the fact that the terms with x, not ax, just the terms with x. The terms with x cubed, the terms with x squared for this year, and the terms without x. We're grouping those together. X cubed plus 3x squared minus 2x plus 17. Now ax cubed is by itself, bx squared, only term with x squared. Now these two both have an x term, so I'll factor that out, leaving us with 4a plus c, plus I'll just put parentheses around this here. Highlighter. Now, this here, our x cubed matched up with our ax cubed. 3x squared matched up with our bx squared. Negative 2x matched up with our x times 4a plus c. And lastly, 17 matched up with our 4b plus d. And really we're not worried, or really what we're more focused on is the leading coefficient, or our coefficients. Not the leading coefficient, because that's only the term in front of the exponent or variable with the highest exponent. We're mainly focused just on the coefficient. So here, 1, let's not use yellow. So here we're saying 1 is equal to a, because there's not a number written in front of x cubed. It is assumed to be 1. Now, b and 3, so 3 is equal to b because those two match up. Now, negative 2 matches up with 4a plus c, and 17 matches up to 4b plus d. And that's how these match up here. Well, a, we know what it is. B, we know what it is. And so we can use the fact that we do know these two here to find the rest. So we'll plug in the value of a here. So I get negative 2 is equal to 4 times 1 plus c. Well, 4 times 1 is just 4, so we have 2 is equal to 4 plus c. We can subtract 4 from both sides. And we see that negative 6 is equal to c. We have the value of c. Now that brings us to our last one. We can plug in the value of b, which we found to be 3. Well, 4 times 3 is 12. And at this point here, we can subtract 12 from both sides. And when we subtract 12 from both sides, I get that 5 is equal to d. So at this point here, we do have the values of a, b, and c. And d, we have the values of all of them. So at this point here, we do have the values of all a, b, and c. We can bring that down here. So we have a, b, and c. Now our original two fractions, our original partial fraction decomposition had ax plus b and cx plus d over x squared plus 4 and x squared plus 4 squared. Now after doing all that math and all that work, we found out the value of a was 1, so we just have 1 here, or I can just write x, I can leave x by itself. B, we found it to be 3. C, we found it to be -6. And D, we found it to be 5. And now we'll leave it like this here. This here is our answer. Now if you're wondering, kind of like the last one where we pulled the negative out front, that is possible. But if we do that, we're changing the sign of everything on top. So to write the negative out here, I have to bring out a negative from the entire top of this fraction. And it would make the 6x positive, but it's going to make the 5 negative. So pulling out a negative doesn't pull it out of just the 6, it also pulls it out of the 5 as well. So either one of these here is the correct answer. Now your homework for this assignment here is going to be on page 508, 31, 33, 34, 37, 38, and 39. So you have these problems here. And that is the end of 7.43.